So will the students be visible to me in this stream?
Yes, sir. They will be able to see you, sir. Once the streaming starts, I will mute myself, sir. 1 second. I think we are live. 1 second, sir. Yes, sir. We are live now. I will mute myself and then I will stop the video. But in case during the session, if you want no ask any doubts, you can ask me also, sir.
Sure, sure. So will the
yeah, you can start now, sir. In case during the session, if you want no ask any doubts, you can ask me also, sir.
Sure. So will
Sir, we are live, sir. You can respond to those questions first in that Google form, then you can proceed with that YouTube chat, sir.
Good afternoon all. So we have got a few questions. Allah Lalit is the student. So he is asking, does a cavity in the UAV body make any difference in the aerodynamics and speed of the UAV, and how would it affect it? Yes, definitely. When there is a cavity, you will be missing the lifting surface there. So it is going to affect the lifting characteristics of the UAV. So you have to compensate that with the additional. Say if you want to install a rotor in the wing for vertical takeoff, for example, right? Then you have to consider. In general, we consider the areas that like the total span times the mean aerodynamic chord. Let us consider a rectangular wing here. Total span times the chord. The span we count it as tip to tip. But if there is a cavity in the wing, say if you are installing a vertical thruster, a motor that helps you for a vertical takeoff, then you have to, while calculating the wing reference area, then you have to subtract that particular point. And moreover, there will be, yes, definitely huge interference with the flow, and whatever the calculations that we are doing and the assumptions we had from the lifting length area and all will not exactly work in that particular. There will be an interference factor that we need to account for. And second question, Sam Surya, how to get a job? No. If you do well, you will definitely get a job. I can promise you that. So if you do well in the academics, you'll be able to get a job. Okay. So the third question is from Mr. Vijay Prakash. He's a student. What he's asking is, what is your thought on monocopter? Does it have any future in commercial applications? Well, in my opinion, any rotor-based, say lift, in case of multi-rotors or a quad rotor, or say a helicopter, the amount of thrust you need to produce is equivalent to the weight of the aircraft, right? And the thrust line is in the the thrust that is generated by individual motors is summed up as the total thrust, and it is acting in the direction of lift in order to lift that particular aircraft. So you have to generate the total thrust equal to the weight of the aircraft, right? Weight of the multi-rotor or a monocopter, whatever it is, helicopter. But in case of, as we discussed during the lectures, in case of fixed wing UAVs, we have something called aerodynamic efficiency, where the thrust line and the lift line are almost, we can say, perpendicular to each other or definitely acting in different directions. So you have like you in T by W for a fixed wing, it is equals to 1 upon L by D, where you have certain aerodynamic efficiency, which is, say, if we even in the worst case, if we consider about 8 to 10, so the kind of thrust that you require to fly the aircraft at the particular flight conditions will be 1/8 of the total weight of the aircraft. Right? So don't you see there is a higher efficiency in a fixed wing? In my opinion, fixed wing have a viable, like poses viable solutions for many of the commercial as well as military applications. Only thing is that you need to augment this fixed wing with this multi-rotors for during takeoff and landing phases. That is when it becomes more viable in terms of commercial applications. Okay. So you need to figure out a way which can be done in an efficient manner. So these are few questions that we got in this response sheet. So the value in the chat box, you can see the value of XCG is not given in the data for problems 4 and 5. Okay, can you please let me know which exercise you're talking about? So we'll try to get back to you on this. So Nitesh, they're asking, so there is some question about missing value of XCG. Is static margin given?
Is static margin given? The information is there. We need to find the static margin.
Yeah, so it is, you have adequate information. In fact, the static margin was given, and all other wing and tail details must be given. Is it a wing alone UAV?
It's a wing alone UAV.
So it's a wing alone UAV. You know what is the neutral point. You take static margin and figure out where should be the CG.
Wing and tail information.
Both are there. Right? So both wing and tail information is there. So adequate information is provided. We should be able to calculate that. Please refer to lecture and put in some energy. Assignment number 6 it seems. Sorry.
So could be also, because the data is missing the data given for this question.
There was an announcement as well related to this particular doubt. You can refer to that. Yeah, Murali.
Yes, sir.
I think everybody else is there. Only one person is as long.
Right, sir. Sir, somebody asked what is UAV. I am not doing IIT, but still I wanted to know. So that question, would you like to answer, sir?
I don't think so. We'll talk about the course. At least those students should register in the course.
Okay. So let's wait for 2 minutes, sir. In case if nobody is posting now, sir, then we will wind up the session, sir. Right, sir. Let's wait for 2 minutes, sir. Hi, sir.
Yeah, Murali.
Ram Tarchana has asked something, sir. Can you just refer it in chat and respond, sir, and then we will wind up, sir.
Just, I just asked him to mail me in detail. Because as far as we are concerned, the adequate data was given. In fact, an announcement was also made.
Sir, shall we wind up the session, sir? Nobody is posting queries.
Yes, sure, sure. If you feel this is adequate, then you can do it.
Okay, sir. I'm ending the stream now, sir.
Okay, thank you.
Thank you so much, sir, for your valuable time.
So,
Bye, sir.
bye.